Okay. Good evening. I'm J. Nageswarao from Ace Engineering Academy. So we'll continue the subject. So last day we discussed the system, control system, open loop system, and closed loop systems. Is it audible? Audible, na? Is it audible? Okay, thank you. Right. Okay. So today transfer function. So transfer function. Transfer function. What is a transfer function? So transfer function is it is a mathematical equivalent model of the system. It is a mathematical equivalent model of the system. Model of the system. It is a mathematical equivalent model of the system. I told in the last day, the word transfer function, the word system, both are same. To the system, we'll write a mathematical form that is called a transfer function. So it is a mathematical equivalent model of the system. What is the definition of transfer function? There are two definitions for the transfer function. The first definition is the transfer function of a linear time invariant system. Linear time invariant system is defined as ratio of Laplace transform of output, Laplace transform of output to Laplace transform of input. Laplace transform of input with all initial conditions are 0. 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 That means simply transfer function equal to Laplace of output by Laplace of input with all initial conditions are 0. So here, this is the first definition of transfer function. But the transfer function analysis valid for only LTI systems. The transfer function analysis valid for only LTI systems. So linear time invariant system. Linear. It is not valid for other systems. It is valid for only linear time invariant system. So what is the linear time invariant system? Which components, which system is called linear time invariant system? When we can say, first of all, system is linear. When we can say system is linear. To say the system is linear with respect to system characteristics, when we can say system linear means the transfer characteristics must be linear. Transfer characteristics must be linear. Transfer means V0 versus Vi. V0 versus Vi. If you draw a car, V naught versus Vi, it should have a linear transfer characteristics. Then we can say that one minute. Okay, is it audible? Audible, na? Okay, okay, thank you. Right. Right. So when we can say the linear transfer, when we can say system linear means the transfer characteristics must be linear. That means output versus input, if you draw, the characteristics must be linear. Which components gives the linear transfer characteristics? The RLC components gives the linear transfer characteristics. The RLC components gives the linear transfer characteristics. Linear transfer characteristics. That's why RLC components are called linear components. For example, see, for example, I'll take a simple resistive network. I'll take a simple resistive network. I'll take the simple resistive network. So I'll take here 1K, here 1K. Here I'll take a, for example, RAM signal. Input is RAM signal, I'll take. Input is RAM signal, I'll take. Then what is the output here? What is the output? V naught equal to Vi into 1K by 2K. 1K by impedance across output by total impedance. Total impedance is 2K. So that means 0.5 times of Vi. So if I draw a transfer characteristics, transfer means V naught versus Vi. If I draw a transfer characteristics, so what happened? Vi 0, then V naught also 0. Vi 1 volt, V naught 0.5. Vi 2 volts, V naught 1. That means if you draw a transfer characteristics, we'll get the linear. So we'll get the linear. RLC components gives the linear transfer characteristics. RLC components gives the linear transfer characteristics. Next. So even if you take not only R resistor network, you take even RC network also. RC network in case if you take. So what is the transfer characteristics? So first here to draw the transfer characteristics, I'll take the first step input, for example. I'll take a step input. First input is 0, for example, 0. What is the output? Tell. If input is 0, what is the output? Output also, first I'll draw with respect to T, then I'll draw the transfer characteristics. So if input 0, output also becomes 0. In case input is 1 volt, for example, input is 1 volt, 1 volt. What is the output? Output also exponentially rise. Then after some time it reaches to the 1 volt. After some time it reaches to the 1 volt. In case input is, for example, you consider 5 volts. The output also what happened? It rises to 5 volts. Then after that it maintains the steady state value 5 volts. So this is the output. The capacitor charges exponentially, na? It charged and then finally reaches the steady state value. Now if I draw a transfer characteristics, V naught versus Vi, if I draw it, V naught versus Vi, you have to consider particular time. For example, at t equal to ts, at the steady state, I'll consider it should be constant, time should be constant. So I'll draw the transfer characteristic at steady state. Steady state means phi tau. Steady state, practically what is the time required to reach steady state? Phi tau. At phi tau, I'll draw. At phi tau, input 0, what is the output? 0. In case input 1 volt, output is 1 volt. Input is 5 volts, output 5 volts. That means what happened? We are getting a linear transfer characteristics. No, sir, I don't want at steady state means you can draw even at any time also. For example, I'll draw at t equal to 1 second. For example, at t equal to 1 second, I want to draw. For example, here t equal to 1 second. At t equal to 1 second, input 0, output also 0. In case input is 1 volt, input is 1 volt, output is what? 0.5. For example, here 0.5 consider. At 1 second, input is 1 volt, but output is what? 0.5 seconds. Input 1 volt, output is 0.5. In case, if input is 5 volts, output becomes what? 5 times, 0.5, na? So it becomes how much? 2.5. It becomes 2 because linear system means input is double means output double. Input rises by 5 times, output also rises by 5 times. So it will become 2.5 seconds. If you draw a transfer characteristics, you will get the linear only. If you draw a transfer characteristics, you will get the linear transfer characteristics. Input double means output double. Input 10 times increase, output 10 times. That is called the linearity. So here what happened? Input here 1 volt, output 0.5. So that means half of the input. At 1 second, input rise to 5 volts. That means so output become a 2.5, half of the what? Output voltage. Then only we can say this is a linear circuit. So simply what you can say, the RLC components gives the linear transfer characteristics. And not only that, the RLC component values not changes with respect to time. The RLC component values not changes with respect to time. That's why simply LTI system is nothing but RLC network. Simply LTI system is nothing but RLC network. In case in RLC network, put a one diode, you put a switch, not diode, any switch you put it. Then the transfer characteristics becomes the non-linear. For example, see, I'll take a simple network with a diode, or I'll take a simple diode here. Cut-in voltage of, for example, 0.6 volts. 0.6 volts. Then, so for example, here I'll take input is ramp signal, for example. So T, VI, a ramp signal I'll take. Up to 0.6 volts, what happened diode here? Up to 0.6 volts, the diode does not conduct. Does not conduct means what? It's just like open circuit. It not conduct means it is just like open circuit. If it is open circuit, what happened? Output equal to input. That means we will get the output equal to input up to 0.6 volts. Up to 0.6 volts, input 0.6 volts, output also 0.6 only. Output 0.6 only. So if input is more than 0.6, then the diode conducts, starts conducting. Then it acts as a battery of 0.6 volts. It acts as a battery of 0.6 volts. That means input 1 volt. What is the output? 0.6. Input 10 volts, output 0.6. So if still more increase, then the diode may spoiled. So that means what happened here? Observe this transfer characteristic which is non-linear. It may be linear up to 0.6, but overall diode characteristics observed or overall transfer characteristics of the system is observed, which is non-linear. That means any device which is having, we can say, on and off characteristics the device we can say that non-linear device. Any device which is having on and off characteristic, then we can say it is a non-linear device because it gives the non-linear transfer characteristics. But RLC components not act as a switch, na? So that's why RLC components are called a linear components. So simply be remember, LTI system is nothing but simply RLC network. And another thing is that in the transfer function analysis, initial conditions must be 0. In the transfer function analysis, initial conditions must be equal to 0. Why it should be 0? Why it should be 0? What is the meaning of initial conditions 0? Initial conditions 0 means the system should be under the rest. No energy stored across the components. System should be rest. System under the rest, and no energy stored across the components. No energy stored across the components. Stored across the components. Across the components. No energy stored across the components or across in the system. Why? Because then only it satisfies, it gives the linear transfer characteristics. Then only it satisfies linearity. Then only the system satisfies or gives the linear transfer characteristics. The system gives the linear transfer characteristics. Linear transfer character. That's why in the transfer function analysis, always initial conditions must be 0. We should not consider the initial conditions. This is about the first definition of the transfer function. Next, second definition. What is the second definition of transfer function? Anybody? Second definition of transfer function. Is it audible now? Voice clear now? Some people are telling voice is breaking. Is it clear? Okay. Yes, correct. Impulse response. Good. So, second definition. So, second definition of transfer function. Definition 2. Second definition. What is the second definition of transfer function? The transfer function of A. The transfer function of A linear time invariant system. Linear time invariant system is defined as Laplace transform of impulse response. Laplace transform of impulse response with all initial conditions are 0. With initial conditions are 0. With initial conditions are 0. With initial conditions are 0. This is the second definition. That means what is the transfer function? Transfer function equal to Laplace of impulse response with all initial conditions equal to 0. Why the second definition actually? It is obtained by first definition only. The second definition obtained by first definition only. For example, see, I'll take a system. For example, I'll take a system. I'll take the system. For example, I'll take the system. That is 1 by s plus 1. System is nothing but transfer function only, na? That is 1 by s plus 1, for example. I'll take input is impulse. I'll take input impulse. Output is called impulse response. Input is impulse. Output is called impulse response. Output is impulse response. So now if we use the first definition, what is the transfer function tell? According to first definition, what is the transfer function? Transfer function equal to Laplace of output. What is the Laplace of output? Impulse response. Laplace of impulse response. Impulse response by Laplace of impulse. Input is impulse, na? What is the Laplace of impulse 1? Laplace of impulse is 1. That means what you are getting? Simply transfer function equal to Laplace of impulse response. That will I written here. Simply it is obtained by first definition only. What is the first definition? Laplace of output by Laplace of input. Laplace of input. Output is impulse response. Input is what? Impulse. So Laplace of impulse is 1. That means it is obtained from first definition only. But then why we need this second definition? Why we require second definition? We don't require second definition. Now, why we required means, listen. Why we require the second definition means, there is a importance for this impulse response. There is a importance for this impulse response. What is that importance means? Impulse response is also called system response or natural response or free forced response. Impulse response is called system response, natural response or free forced response. See, one more thing you should know, the output always called with the name of input only. Impulse response means input should be impulse. Unit step response means input should be unit step. Parabolic response means input should be parabolic. Always the output called with the name of input only here. Output called with the name of input only. Be remember. So why it is called system response, natural response or free force response means, get the screenshot. So why it is called system response, natural response or free force response means, listen. For example, I taken a system. What is the system I taken? 1 by s plus 1 I taken. I taken here, system is 1 by s plus 1 I taken. So that means C of s by R of s equal to 1 by s plus 1. 1 by s plus 1. It is a system. 1 by s plus 1, it is a system. If I consider input is impulse if I consider, what is R of t? Del of t. R of s equal to what? 1. R of s equal to 1. Then what is C of s? C of s equal to what we are getting? 1 by s plus 1 into R of s, means into 1. This 1 by s plus 1 is a system. So system. This system product with 1. So that anything will change? Anything will change? No change. There is no change. No term is added to the system. Then if apply inverse Laplace transform, so then C of t equal to inverse Laplace transform. Apply what I will get? 1 into e power 1 into e power minus t. Default u of t you will get. Default u of t. So here 1 into e power minus 1t u of t belongs to the system. This e power minus 1t because of 1 by s plus 1, na? So this is because of the system. Whatever the nature you are getting, that is called purely system nature. The impulse response does not consist any input term. It consists only system response. It consists only system response. If I draw the response, for example, if I draw the response, this is t, this is c of t, 0, t 0 means 1, t infinity, e power minus infinity 0, that means exponentially decay. It reached steady state at 5 tau. It reached steady state at 5 tau. 5 tau. That means what is the nature of this system? Exponential decay. The nature is exponential decay. The nature of the system is exponential decay. We can say even system is stable because bounded output. Bounded output, we can say system is stable. So whatever the nature you are getting here, this is called purely system nature. It is a system behavior. It is purely system nature or system response because there is no input term present in the what impulse response. That's why impulse response is called system response, natural response, free force. There is no force term. Force term means input term. That's why it is called a natural response. For example, just for understanding, I'll take unit step input, for example. I'll take unit step input. For example, I'll take unit step input. What happened? R of t equal to 1 into u of t. R of s equal to 1 by s, for example. Then what happens? C of s equal to what? C of s by R of s is 1 by s plus 1 is the system. Then C of s can be written as what? So R of s, take it other side, it will become 1 by s. That means what I can write? 1 by s plus 1 into, it is a belongs to the system. 1 by s belongs to the input. That means one extra term is added. Because of this extra term, what happened? Because of this extra term, we don't get exact system response. Here exact only system terms are there. But here additional term added. Then I cannot call it is a system behavior, or I cannot call it is a system response. I cannot call it is a natural response. Why? Because if I find partial fractions, what I will get? 1 by s minus 1 by s plus 1. If I find inverse Laplace transform, what we will get? 1 minus e power minus 1t default u of t. Now this e power minus t we got because of the system only. This is because of the system. But this is because of input. There is a term which related to the input, that is called 1. Because of this input term, what happened? Simply the output follows the input. If I draw a nature here, if I draw the nature, this is t, this is c of t. For example, this is unit step 1. Then what is the output we are getting? What is the output we are getting? T equal to 0. E power 0, 1. 1 minus 1, 0. T infinity, e power minus infinity, 0, 1. That means what happened? Exponentially rises, reaches to 1. That means what is the output? Simply the output follows the input. Output follows the input. Then what is the nature of the system here? We cannot identify the nature. If there is no input, we can say whatever the output you are getting, that is a system nature. If there is no input, whatever the nature you are getting, that is the system nature. But here, because of the input, simply follows the input. We cannot identify the nature. For example, if I take a ramp signal here, if I take a ramp signal, simply it follows the ramp. If I take a parabolic, simply it follows the parabolic. Then we cannot identify the nature of the system. That's why step, ramp, parabolic responses are called forced responses. Step, ramp, and parabolic responses. Parabolic responses are called forced response are called forced response are called the forced response. Step ramp parabolic responses are called forced response, whereas impulse response is called natural response. This is called natural response. Natural response, natural response, or system response, or free forced response. Okay. So if anybody asks find system response, what you have to find? You have to find the impulse response. If you ask find system response, we require to find the what? System response means it is nothing but what? Natural response. Even ask find system stability, what you have to do? You have to find impulse response and you have to substitute t tends to infinity. T tends to infinity. If it gives the bounded value at t tends to infinity, the value is bounded, then it is called a stable system. If it is unbounded, then it is called unstable system. Okay. So this is about the impulse response. Okay. This is about the impulse response. Next, get the screenshot, or otherwise they will send it. After the class, they'll send all these files, PDF files. Next. So transfer function completed. So two definitions. One is Laplace output by Laplace input. The second one is Laplace of impulse response. Next, we'll go for basics. Some basics we'll discuss. What is a pole? What is a zero? What is a characteristic equation? What is the importance of time constant? All the basics we'll discuss. Listen carefully. Then only can understand. Okay. Listen. So basics. And note down important points also. You put one notes and then you note down. If you write, then it will be better. Some points. Okay. Even though you'll get the PDF, better note down some points which you don't know. So for example, for now come to the basics. So here be remember, any system basically they defined in terms of open loop transfer function. I told in the last day, either you remembered or not. I told the last day, any system, listen, any system basically defined as or described as defined in terms of open loop transfer function. Defined in terms of open loop transfer. It may be open loop system, it may be closed loop system. They defined in terms of open loop transfer function only. They defined in terms of open loop transfer function only. First, I'll take open loop system. For example, first I'll take the open loop system. Open loop system. I'll take open loop system. So open loop system is defined as what? Open loop transfer function of a system. Open loop system is defined as open loop transfer function of a system. Open loop transfer function of a system. That is G of S equal to K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power n into 1 plus S tau a. It is a standard form of mathematical model of open loop system. It is a standard form of mathematical model of a open loop system. Here, what this K and tau are called what? System parameters, where K and tau are system parameters. System parameters. K and tau are system parameters. And K is known as system gain. K is known as system gain. K is known as system gain. Tau is system time constant. Tau is system time constant. Tau is system time constant. It is a system time constant. N represents the what? N. S power N. N represents the type. Type N system. N represents the type N. Type N system. Type N system. What gives the type of open loop system? It is very important. Type and order. Type of open loop system. Type of open loop system. What is the definition of type of open loop system? So it is a number of open loop poles at origin. Open loop poles at origin in open loop transfer function. In open loop transfer, it is a number of open loop poles at origin. It is number of open loop poles at origin in open loop transfer function. In open loop transfer function. Okay. Next, it is a number of open loop poles at origin in open loop transfer function. So next, order of a system. Order of a system. Order of a open loop system. Order of open loop system. What is the order of open loop system? What is the order of open loop system? It is a total number of open loop poles. Total number of open loop poles in the open loop transfer function. In the open loop transfer function. So if system is open loop, type represents the number of poles at origin in the open loop transfer function. Order represents the total number of poles in the open loop transfer function. In case if I take a closed loop system, for example, I'll take a closed loop system. Closed loop system. For example, I'll take a closed loop system. So closed loop system defined as, it is defined as what? Open loop transfer function of a unity feedback system. Unity feedback system. Closed loop system defined as open loop transfer function of a unity feedback system. That is G of S equal to K into 1 plus S tau 1. Same thing. 1 plus S tau. What is the difference here? Extra is feedback, that's all. Mathematical model for open loop, closed loop, same. Only in the closed loop, feedback is exist. That is, what is the feedback here? H of S equal to 1. This is a mathematical standard form of the closed loop system. It is a standard form of closed loop system. Okay. Now, here type and order. Type and order. So type of the type. 1 minute. Type of closed loop system. Type of closed loop system. What is the definition of type of closed loop system? What is the definition of type of closed loop system? It is very important. Why? Because many times they asked, especially in IES, ESC, they asked many times, even in the gate also. Find the type and order of the closed. They will give the closed loop system, they'll ask find the type and order. Most of the students, they'll do the mistake. They'll write type and order both for closed loop transfer function. It is wrong. So for type you have to observe open loop transfer function. For order you have to observe closed loop transfer function. Type of closed loop system. It is a number of open loop poles at origin in open loop transfer function of a unity feedback system. Unity feedback system. So it is a number of open loop poles at origin in open loop transfer function of a type valid for only unity feedback. Type not valid for non-unity. Non-unity given, again you have to convert into unity feedback. Why? Because type is linked with steady state errors. Type is linked with steady state errors. Steady state errors also valid for unity feedback. Type also valid for only unity feedback systems. So it is valid for only unity feedback. So next, order of closed loop system. Get the screenshot if you want. Next, order of closed loop system. 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 What is the definition? Order of closed loop system. It is a total number of closed loop poles. It is total number. It is total number of closed loop poles in closed loop transfer function. In closed loop transfer. What do you understand here? For order, we have to observe the closed loop transfer function. For type, you have to observe the open loop transfer function, where h of s should be 1. For type, you have to observe open loop transfer function. Be remember the definition. Don't get confused. Open loop system means for both the things open loop transfer function only. But when system is closed loop, that means in the given system mentioned feedback or h of s, then for type you have to observe open loop transfer function. For order we have to observe closed loop transfer function. Okay, na? Next. So we'll solve some problems. Okay, so that it will become perfect. Note down the question. Note down the question. The open loop transfer function of a, note on the problem. The open loop transfer function of a unity feedback system. Unity feedback system is g of s equal to s plus 1 whole cube divided by s square. S plus 1 whole cube divided by s square. Find the type and order of the system. Find type and order of the system. Find the type and order of the system. Come on, find it. Tell the answer. Practically unstable systems are not exist. Practically available only stable and marginal stable system. Example for marginal stable is oscillators. Unstable systems are not exist. What is the type? What is the order? Anybody? Type represents the number of integrators present in the system. Type indicates the number of integrators presented in the system. Number of integrators we can identify only in the open loop form. Actually, type indicates number of integrators presented in the system. Number of integrators presented in the system. That number of integrators we can identify only in the open loop transfer function of unity feedback system. We cannot identify number of integrators once you find a closed loop transfer function. That's why type defined for only open loop transfer function. It is not defined for closed loop transfer function. So type significance is type represents the number of integrators presented or existed in the system. Okay. Order represents the number of storage elements or number of time constants present in the system. That is secondary. So now you find here type and order. So first, given open loop first of all, given system open loop or closed loop, very clearly mentioned feedback. That means given system is a closed loop system. Given system is a closed loop system. It is a closed loop system. Given system is closed loop system. Given closed loop system. So now what is the definition of type? First find the type. So for type, what is required? For type required is what? Open loop transfer function required. That is G of S and H of S should be 1 because it is closed loop system. For type required, G of S, H of S should be 1. Given also G of S only, H of S 1. What is the G of S given? G of S equal to, directly we can write type because G of S only given. Required also G of S only. So S square, H of S is 1 is given. That means directly I can write the type. What is the type here? Tell. Type 2 system. It is a type 2 system. Next, find the order. Next, find the order. What is the order? Tell. For order required what? For order required what? Closed loop transfer function. Closed loop transfer function. For order required closed loop transfer function. So that means find closed loop transfer function. C of S by R of S equal to G of S by 1 plus G of S. G of S by 1 plus G of S. Now tell what is the closed loop transfer function? S plus 1 whole cube by S square. Simply what I told, how to find closed loop transfer function. Just add the numerator term in the denominator. Just add numerator term in the denominator. Just add it. It will become closed loop transfer function. How it is means it will come in the next problem. S plus 1 whole cube. Now what you are getting? What is the answer? Tell. S plus 1 whole cube divided by. So expand this. S cube plus 3S square plus 3S. 3S square plus here S square is there. That means 4S square. 4S square plus 3S plus 1. That means what is the order? Order of the system is what? 3. Type is 3. Type is 2. Order is 3. Order of the system is 3. That's all. Like this. Don't say type 2, order also 2. Type is for open loop. Order is for closed loop transfer function. So like this, you have to get the type and order of the given system, given closed loop system. Next, one more question. Note down one more question. Next question. Next problem. Write it. The impulse response of a, you should solve, I should not solve, you should tell the answer. The impulse response of a unity feedback system is C of t equal to minus t e power minus t plus 2 e power minus t. u of t. Find type and order of the given system. Find type and order of the given system. Come on, do it. Tell the answer. Post your answer in the question and answers. Come on. Tell the answer. Type 2, how many poles at origin here? 2 poles at origin. That's why it is type 2 system. What is the definition of type I told just now? The number of poles at origin, open loop transfer. How many poles at origin? 2. So it is a type 2 system. Order means total number of closed loop poles. How many poles here? 3, third order. So order 3. Listen carefully. Read the definition. The open loop transfer function, how many poles at origin? Observe. That gives the type. Come on, tell the answer. Type 0, order 2. Type 3. Type 0, order 2. First of all here, the given response is open loop system response or closed loop system response? Anybody? The given response is open loop system response or closed loop system response? Closed loop response. Yes. Type 2, type 1, order 2. Type 2, order 2. Most of the students, some students, they put the correct answer. Listen here. The given response is closed loop system response because very clearly mentioned feedback. Mentioned feedback here. That means it is a closed loop system response, not open loop system response. So that means you will get the first closed loop transfer function. You will get closed loop transfer function. What is the closed loop transfer function? Laplace of impulse response. Laplace of impulse response. So with all initial condition 0. Apply Laplace transform. This is impulse response only, very clearly mentioned now. So Laplace of what is impulse response? Minus t e power minus t plus 2 e power minus t. Apply Laplace transform, then you will get closed loop transfer function. So what it is tell? So Laplace means what I will get? Minus 1 by s plus 1 whole square plus 2 by s plus 1. Then LCM you take, denominator s plus 1 whole square, here minus 1 plus 2 into s plus 1. Then if you solve this, 2s plus 1 by s square plus 2s plus 1. This is the closed loop transfer function. From closed loop transfer function, what we can obtain? We can obtain the order. Now I can write the order here. So that means what is the order here? Tell order. What is the order? It is a second order. Order 2 na second order. Because for order required what? Closed loop transfer function. For order required closed loop transfer function. This is a closed loop transfer function. That's why order is 2. Next, we'll go for type. For type, what is required? Open loop transfer function required. Open loop, how many poles at origin? We have to find it. That can be obtained only in the open loop form. So I need open loop transfer. That is called G of S. What it is? It is closed loop transfer function. So that is what C of S by R of S equal to what you got? G of S by unity feedback na 1 plus G of S. That equal to what you got? 2S plus 1 by S square plus 2S plus 1. So this is a closed loop transfer function. From this, what do you want? Open loop transfer function you want. That means G of S we want. So from this, simplify this. For example, this can be, take the inverse, take the ratio, inverse you take. That means 1 plus G of S by G of S equal to what I can write? S square plus 2S plus 1 by 2S plus 1. So now this can be written as what I can write? 1 by G of S plus 1 equal to what I can write? Same thing na, S square plus 2S plus 1 by 2S plus 1. Now we find 1 by G of S. 1 by G of S equal to S square plus 2S plus 1 by 2S plus 1. When you take it other side, it become minus 1. Then take the LCM and find G of S. So what I'll get? 1 by G of S equal to S square plus 2S plus 1. Take it here LCM. Here you'll get minus 2S plus 1 divided by 2S plus 1. Now this to cancel. Then G of S becomes what? Finally, what is the G of S you got? Finally, G of S equal to open loop transfer function 2S plus 1 by S square, where H of S is 1. So for type, what is required? For type, what is required? G of S only, H of S 1. That means what I can write? Type equal to, for type always required G of S, H of S 1. So now how many poles at origin here? 2 poles at origin. That means type is 2. 2 poles at origin in the G of S. That means type 2. That means it is a type 2 and order 2 system. It is a type 2 and order 2 system. Okay, na? So like this, you have to find type 2 and order. In case they ask find system gain, how will find the system gain? How you will find the system gain? For example, if you ask system gain, for example, ask the system gain. So which system gain? Closed loop system gain. So if it is closed loop system gain, it is obtained from closed loop transfer function. Open loop system gain is obtained from open loop transfer function. For example, I want closed loop system gain. So how can I obtain the system gain? So you should bring the transfer function into time constant form. Then you will get K into 1 plus S tau 1, 1 plus S tau 2. That K is called the system gain. If you find from closed loop transfer function, then it is closed loop system gain. If you find from open loop transfer function, then it is called open loop system gain. For example, I want a closed loop system gain. What is the closed loop transfer function then? Closed loop transfer function is C of S by R of S equal to 2S plus 1 by S square plus 2S plus 1. This can be written as 1 plus 2S by 1 plus S whole square. That's all. So now what is the, this is in time constant form only na. So here what is the system gain? 1. System gain, it is in like this form na, K into 1 plus S tau plus 1 plus S tau 2. Yes or no, and so on, divided by S power N into 1 plus, like this form na. So what happened here? What is the system gain we are getting here? 1. System gain is 1. So this is 1 na. Common factor, whatever, after adjusting into time constant form, whatever the constant is there, that is called system gain. So K equal to 1. So closed loop system gain. Closed loop system gain K equal to 1, or you want to put it KCL, K of closed loop system, or simply already we written closed loop system gain equal to 1. This is the way you have to find it. But what happened? Sometimes what happened here, for example, closed loop transfer function order is more. We are unable to bring it in this form. For example, here s cube plus 3s square plus 4s plus 5 is there. I cannot bring into factors form because roots cannot find. In that case, if you ask the closed loop system gain, simple logic is this formula be remember. It is valid for open loop as well as closed loop. Be remember. System gain equal to simply numerator constant by denominator constant. Numerator constant by denominator constant. Numerator constant by denominator constant. So this formula we can apply for open loop system gain as well as closed loop. If you want open loop system gain, in the open loop transfer function, I'll take numerator constant by denominator constant. If you want closed loop system gain, this formula I'll apply to the closed loop transfer function, numerator constant by denominator constant. What is the numerator constant tell here? In the closed loop transfer function, this is closed loop transfer function. Na? What is the numerator constant? 1 na? 1. So 1 by denominator constant also 1. So 1 by 1 becomes the 1. Simply numerator constant also 1, denominator constant also 1. That means it will become 1 by 1. So system gain equal to 1. So either in the factor form or either in the expanded form, whatever it is, simply follow this. Directly will get the system gain. Okay. Okay, we'll solve one more problem, you can understand. And one more thing here. See, from closed loop transfer function, we obtained open loop transfer function by going by the procedure. But simple shortcut is, listen, simple shortcut is, get the screenshot if you want. Simple shortcut is, listen. So what is the closed loop transfer function? Okay, listen. Right, listen. So here, 1 minute, listen. First, I'll take closed loop transfer function. What is the closed loop transfer function? C of S by R of S equal to G of S by 1 plus G of S is a closed loop transfer function. G of S by 1 plus G of S is a closed loop transfer function. From this, I want to obtain open loop transfer function. From the simple shortcut I am telling. From this, I want to apply, I want to get open loop transfer function. Simply what I want to say, just to subtract the numerator term in the denominator. Just subtract it. If subtract, what happened? G of S cancel. What is left to tell? Only G of S. The left is G of S. G of S is called what? Open loop transfer function of unity feedback system. Open loop transfer function of a unity feedback system. That means when you want to get open loop transfer function from closed loop transfer function, just subtract the numerator term in the denominator. In case open loop transfer function given, G of S given, just G of S given. We want closed loop transfer function. Just what you do, no term in the denominator means 1. Na? No term in the denominator means 1. No term in the denominator means 1. Na? Just add the numerator term in the denominator. just add the numerator term in the denominator. Then it will become what? Closed loop transfer function. That means when you want to get closed loop transfer function, add the numerator term in the denominator to get, note, to get open loop transfer function from closed loop transfer function, subtract the numerator term, subtract the numerator term in the denominator. Numerator term in the denominator. Subtract the numerator term in the denominator. So when feedback is unity, it is valid only for unity feedback. It is not valid for the what? Non-unity feedback system. It is valid for only unity feedback. To get closed loop transfer function, from open loop transfer function, add the numerator term, in the denominator. Denominator, okay. Numerator term in the denominator term. Just add numerator term in the denominator term. Just add it. Automatically you will get the what? Automatically you will get the open loop transfer, closed loop transfer. Closed loop you want, add it. Open loop you want, subtract it. That's all. Remember this. But it is valid only unity feedback. When feedback is unity. It is valid for only unity feedback system. Okay, na? Next, one more question. We'll solve one more problem. System gain is different, DC gain is different. DC gain means put the S equal to 0. DC frequency 0, na? DC signal frequency 0. So put S0, whatever the answer we are getting, that is called DC gain. Okay, sometimes if one pole at origin is there in case, for example, C of S by R of S equal to 2S plus 1 by S into S square plus 2S plus 1 is there. What is the DC gain here? Infinity. But system gain is 1 only here. System gain is 1 because if adjust into time constant form, what I can write? 1 into 1 plus 2S divided by S into 1 plus S whole square. So this is the time constant form. If you write, what is the system gain? 1, or numerator constant by denominator constant 1 by 1. It will become 1 only. After taking S terms common, whatever the constant is there, that you have to consider as denominator constant. Or simply adjust into time constant form. Whatever the constant is there, that is called system gain. So DC gain means simply S0. That means here DC gain infinity. System gain means 1 here. So DC gain means simply substitute S tends to, DC gain means simply substitute S tends to infinity. Okay. Next. Okay. One minute. 1 minute. Right. Okay, no problem. Right, next. Next problem. Note down the next question. Next problem. Right. The unit step response of a, the unit step response of a, unity feedback system is, unity feedback system is, the unit step response of a unity feedback system is C of t equal to 1 plus e power minus 40 minus 2 e power minus 2t u of t. Find type and order. Find type, order and system gain. Order and closed loop system gain. Closed loop system gain. Come on, do it. Solve it. Tell the answer. What is the answer? Anybody? One minute. Anybody answer? Unity feedback means H of S1. How it is H of S1 means unity feedback. Unity feedback means H of S1. Now it is a what? Closed loop system or open loop system? It is a closed loop or open loop? Feedback mentioned means given system is closed loop system. Given system is a closed loop system. Given closed loop system. Now find closed loop transfer function. What is given? Unit step response given. Given unit step response. Then use the, find the transfer function first. What is the transfer function? Laplace of output by Laplace of input with all initial conditions 0. So closed loop transfer function equal to Laplace of output by Laplace of input. What is the output? Unit step response. Laplace of unit step response. Laplace of unit step response divided by Laplace of unit step. Unit step response means input should be unit step. So Laplace of unit step input. Unit step input. So with all initial conditions are 0. Laplace of unit step input. With all initial conditions are 0. With all initial conditions are 0. Now come on. Find the transfer function. So transfer function, come on. Closed loop transfer function. C of S by R of S equal to Laplace of, what is C of T, tell? 1 plus 1 plus e power minus 4t minus 4t minus 2 e power minus 2t divided by Laplace of 1 u of t. Because step na, unit step na. So then get the answer. 1 by s plus 1 by s plus 4. Next minus 2 by s plus 2 divided by Laplace of unit step means 1 by s. Now find closed loop transfer function. You find closed loop transfer function. C of s by R of s equal to C of s by R of s equal to, come on, find it. Numerator. So LCM you take and find, come on. If you take LCM, what you are getting? S into S plus 4 into S plus 2. Get the answer. What happened? Numerator term, what I will get here? S plus 2 into S plus 4. Then plus S into S plus 2 minus 2 into S into S plus 4. Divided by what? 1 by S. This SS cancel. Then I can write it as, bolo, denominator what I will get? S plus 4 into S plus 2. Numerator expand it. S square plus 4 plus 2, 6S plus 8. Plus S square plus 2S. Minus 2S square minus 8S. Now simplify this. Come on. So what happened? S square minus 2S square cancelled. 6S plus 2S, 8S minus 8S cancelled. What is the answer finally? 8 by S plus 2 into S plus 4. It is a closed loop transfer function. It is a closed loop transfer function. So now, what is this is a closed loop transfer function. Now I can write here what? Order. What is the order of the system? Order is 2. Order of the system is 2. This order is 2. Next, find the type. So for type required what? G of S. How to find G of S? Subtract the numerator term in the denominator. That means 8 by S square plus 6S plus 8. Just subtract the numerator term in the denominator. Minus 8, 8 cancel. That means what is G of S? 8 by S square plus 6S. This can be written as 8 by S into S plus 6. So H of S is 1. Unity feedback, na? H of S is 1. That means what is the order? What is the type here? So type equal to how much? 1. It is a type 1 system. It is a type 1 system. For type required what? Open loop transfer function. G of S only, na? H of S should be 1. For type required G of S, H of S should be 1. So it is a type 1 system. It is a type 1 system, order 2. Next, find the closed loop system gain. Closed loop system gain. Closed loop system gain. Closed loop system gain. So first take closed loop transfer function. C of S by R of S equal to 8 by S plus 2 into S plus 4. Simply numerator constant by denominator constant. What is the numerator constant? 8. Denominator constant 2 into 4. Means how much? 1. So simply closed loop system gain is 1. Or no, sir, expanded form I'll consider, means even you consider expanded form also same answer. If you expand this, what I will get? 8 by s square plus 6s plus 8. So what is the k? Tell. K equal to numerator constant 8, denominator constant 8. Answer is 1. Either it may be expanded form or it may be factor form. The answer is not going to be changed. The answer not changes. So for type, always observe open loop transfer function. For order, always observe closed loop transfer function. Be remember this. Okay. So next, one more question. Okay. Next, one more question. Next. Next, note on one more problem. Find the system gain and type and order. Find system gain, type and order of the given system. C of S by R of S equal to 10 into S plus 5 whole square by S square into S plus 2 whole square into S plus 10. Come on, tell the answer. Tell the answer, anybody. Tomorrow onwards, our class 6 o'clock. Now, tomorrow onwards, I'll give the break. 6 to 7:30 or 7:45. 7:30 I'll take 10 minutes break I'll give. Again, I'll continue the slot. I'll tomorrow onwards. But today 6:30 to 9 only, na? So 6:32 up to 8:45. I'll continue the class. From 8:45 to we'll discuss the doubts. Okay. So another now 8 now 45 minutes. Another 45 minutes. If I give the break again, problem. Tell the answer, anybody. Type is 2. Order 5. Good. Gain 25 by 4. Very good. Yes. Here given system is what? Okay. Listen. Another 45 minutes. Listen. Here given system is what here? Open loop system, because there is no word of feedback here. There is no word of feedback, na? There is no word of feedback. No feedback mentioned. No feedback. No feedback. No feedback. So no feedback means it is a open loop system. It is a open loop system. For open loop system, how we will get the type? For open loop system, how we will get the type? Directly from open loop transfer function. Type is number of poles at origin. 2 poles at origin. It is a type 2. Order. Next, what happened? Order. So what is the order? Total number of open loop poles. How many poles? 2 plus 2 plus 1 means order is 5. Okay. Numerator constant. 10 into 5 square. 10 into 5 square divided by 2 square into 10. 2 square into 10. Numerator constant by denominator constant. 10, 10 cancel. So 25 by 4. The system gain, I think 6.25 will get. I think 6.25 will get. 6.25 will get. So like this you have to get. Even if you convert into time constant form, you'll get 6.25 only. You'll get the 6.25. That's all. Like this you have to get the system gain. Okay. Next. One break, huh? One break. Okay, next. Many students are telling no, so no break. Okay, next. Next, go for characteristic equation. Next, go for characteristic equation. Characteristic equation. Characteristic. What is the characteristic equation? Anybody? What is the characteristic equation? So it is a what? Denominator of the transfer function. Make equal to 0. Then it is called a characteristic equation. Why it is called characteristic equation? Characteristic equation gives the system characteristic, system behavior. Characteristic equation gives the system characteristic, system behavior. What is the characteristic equation? Means the denominator of the transfer function make equal to 0. Make equal to 0. Make equal to 0. Then it is called characteristic equation. Then it is called characteristic equation. Characteristic equation. Why the denominator is called characteristic equation? Why not the numerator? Numerator can consider as a characteristic equation? No. The denominator will decide the characteristics of the system behavior. For example, see, for clarification, I'll take one simple example. So, for example, C of S by R of S equal to S plus 1 by S plus 5 and S plus 10, for example. So, we'll find system characteristics by considering impulse input. Impulse input only called system response. Impulse input only gives the system characteristics. So, input should be considered impulse. If you consider impulse, R of S becomes 1. Na? Because of the impulse, R of S becomes 1. R of S 1. Then this can be written as, so we can write this some K1 by S plus 5 plus some K2 by S plus 10. Can I write like this? K1 by S plus 5 plus K2 by S plus 10. If I apply inverse Laplace transform, so then I can write C of t equal to K1 into e power minus 5t plus K2 into e power minus 10t. I can write like this. Now what is the nature here? The output consists only denominator term e power minus 5t because of S plus 5 got. E power minus 10t we got because of S plus 10. That means C of t consists only denominator term. What is the nature means? If it t equal to 0, if t equal to 0, what happened? If it T0, what happened? T0 means what we are getting? K1 plus K2 we are getting. T0 means K1 plus K2 we are getting. T infinity means what happened? E power minus infinity 0, exponential decay. E power minus infinity 0, exponential decay. That means what is the nature here? Exponential decay. Exponential decay, which is decided by denominator term. Is there anywhere s plus 1 here? One term is there. One is there in the output. One is not exist in the C of t na? Okay, why all these things? I'll put here minus 1. Is anything change in the output? S minus 1 I'll take. Is anything change in the output? There is no change because the term just affect this K1, K2 value only. This e power minus 5t not changes, e power minus 10t not changes. That means the nature decided by only denominator term. In case I'll put here minus 5, the nature is going to be changed. Why? Because here s minus 5. Minus 5 means here s minus 5. S minus 5 means e power plus 5. E power plus 5t means exponential rise to infinity. Exponential rise to infinity. That means the nature is going to be changed. That means the nature decided by only denominator term. That's why for system behavior, or characteristics, we consider only denominator terms. We consider only denominator terms. Okay. Next. One minute. Right. So here I'll take it plus only. Plus. Here what happened? Plus. Here minus. So that means the system characteristics decided by only denominator term. That's why for characteristic equation, consider only denominator of the transfer function, make equal to 0. Then it is called the characteristic equation. Okay. For a closed loop system, what is the characteristic equation? Tell 1 plus gh equal to 0. Characteristic equation is 1 plus g of s h of s equal to 0. Denominator of what is the closed loop transfer function? 1 plus g of s h of s. So that's why 1 plus g of s h of s equal to 0 gives the characteristic equation of closed loop system. For open loop system means simply denominator of the open loop transfer function make equal to 0. Then you will get the characteristic equation of open loop system. Characteristic equation of open loop system means simply denominator of the open loop transfer function. That's all. Okay. Closed loop system means 1 plus gh, or denominator of the closed loop transfer function is called characteristic equation of closed loop system. Okay, na? Next. The roots of characteristic equations are poles. What are the roots? Roots of characteristic equations are nothing but what? Poles. How to obtain the poles means, what is the definition of pole? Pole definition is what? Tell. How to find the poles? Tell. How you obtain this pole? What is the pole location here? 2 poles at origin, 1 pole at minus 2, 1 pole at minus 10. Sir, no? What are the poles? 2 poles at origin. Yes or no? 1 pole, 2 poles at minus 2, 1 pole at minus 10. What are the zeros? At minus 5. How we got these poles? Anybody? How you got these poles? Simply roots of denominator of the transfer function. Pole is nothing but roots of denominator of the transfer function. Roots of denominator of the transfer function. Roots of denominator of the transfer function is called pole. What is a 0? Roots of numerator of the transfer function. Roots of numerator of the transfer function. Numerator of the transfer function. Pole is nothing but roots of denominator of the transfer function. 0 is nothing but roots of numerator of the transfer function. Actually, poles and zeros are what? System time constants. Poles, zeros are system time constant actually. But if you say the definition pole in terms of time constant, then problem is complex poles also is there. Then for complex poles, we cannot define. That's why that is a problem. For complex poles, time constant is there as well as frequency of oscillation is there. That's why simple logic. What is a pole means anybody asks simply is the roots of denominator of the transfer function. 0 means roots of numerator of the transfer function. Okay? Next, time constant. Actually, it is a, strictly speak, what is a pole means. For example, if I take a time constant form, what is the time constant form? C of S by R of S or G of S if you take. If I take G of S, what happened? K into 1 plus S tau 1 and so on. In this form, if I consider 1 plus S tau A in this form, if I consider, what is a pole means? If I make equal to 0 denominator, what I will get? S equal to minus 1 by tau A minus 1 by tau B. That means what is a pole? Negative of inverse of time constant. Negative of inverse of system time constant. It is a inverse of time. Even 0 also. What is a 0? Numerator make equal to 0. What I will get? Minus 1 by tau 1 minus 1 by tau 2. That means what happened? The poles and zeros are called time constants only. Poles and zeros are called time constants only, which is obtained by system. In case system not having time constant, we don't get any pole, we don't get any zero. For example, see, I'll take a resistive circuit. For example, I'll take a resistive circuit like this. For example, I'll take a resistive circuit like this. So VI, V0. What is the time? What is the pole here? How many poles are there? How many zeros are there? Find the transfer function. V0 of S by Vi of S equal to what you are getting? Tell R2 by R1 plus R2. R1 plus R2. That means what happened here? Tell there is no time constant. It is a constant only. There is what is the order? Zero order. Zero order. There is no pole, no zero. Here no pole, and no zero. No pole, no zero because no time constant. Because no storage element. Because no time constant. No time constant or no storage element. No storage element. That's why order is 0. No storage element. No storage element. No storage element. For example, I'll take RC circuit. For example, you take RC circuit. RC circuit. RC. V0. VA. RC. Now tell what happened? How many poles are there here? Laplace of capacitor 1 by SC. V0 of S. VI of S. What is the transfer function? Tell V0 of S by VI of S equal to what I will get? 1 by SC by R plus 1 by SC. Then what you are getting? 1 by SCR plus 1. That means this equal to what I can write? 1 by S tau plus 1. 1 by S tau plus 1. That means it is called time constant. For what is the pole location? Tell S equal to what? Minus 1 by tau. Pole is nothing but minus 1 by tau. That's why poles and zeros are nothing but poles and zeros. Poles and zeros. Poles or zeros are nothing but negative of inverse of system time constants only. Poles or zeros are nothing but negative of inverse of system time constants only. Inverse of system time constant. If there is no storage element, then you don't get any pole, you don't get any zero. System time constants only. system time constant. Storage element compulsory required to get the poles and zeros. Otherwise, you will get the simple constant. You don't get any pole, you don't get any zero. Because one time constant, we got one pole. So we can identify number of poles even by looking a electrical network. Electrical network, you can identify, almost you can identify. Some cases it may be cancelled with the numerator, then we cannot identify. But most of the cases we can identify the number of poles. But we cannot identify number of zeros by looking at what network. We cannot identify number of poles by looking at network. Because how many time constants are there, if you find, then that means number of poles will be there. If you want to find zeros, you have to find the transfer function. There is no alternate. So be remember, poles or zeros are nothing but negative of inverse of system time constant only. If the system does not consist any storage element, any time constant, then you don't get any pole, you don't get any zero. Okay. So next, time constant. Next, time constant. Okay. Time constant. What is the time constant? Anybody? What is the importance of time constant first? What is the importance of time constant? Time constant gives the speed of the system. Time constant decides the speed of the system. Time constant decides the speed, na? Decides speed of the system. Speed, or I can say, if the time constant is very, very large, we can say the what? Slow response. The time constant gives the system one way behavior, quick response, slow response, what it is, it gives. If a time constant very, very large, what I can say? Slow response system. It is a slow response system. Time constant very large means it is a slow response system because it takes large time to reach the steady state. Takes large time to reach steady state. Large time to reach steady state. Because large time it takes large time to reach steady state. Steady state. If a time constant very large, then it is called slow response system because large time to reach the steady state. So how many time constant is take to reach the steady state? Practically, any system takes 5 time constant to reach the steady state. Practically, any system takes 5 time constants. Takes 5 tau time constants to reach steady state. To reach steady state. Theoretically means infinity. At what time it reaches the steady state means theoretically it is infinity. But practically it is 5 tau. So with the 5 time constants, it reaches the steady state. With 5 time constants, it reaches the steady state. What is the definition of time constant in terms of pole location? Tau equal to minus 1 by tau equal to minus 1 by real part of the dominant pole. Real part of the dominant pole. Real part of the dominant pole. Minus 1 by real part of the dominant pole. Minus 1 by real part of dominant pole. So this is the time constant. What is the dominant pole? The pole which is close to the imaginary axis. Dominant pole. Dominant pole. Dominant pole. What is the dominant pole? The pole which is close to imaginary axis. The pole which is close to imaginary axis. Imaginary axis is called the dominant pole. Is called the dominant pole. Tau equal to minus 1 by real part of the dominant pole. So dominant pole means the pole which is close to the imaginary axis. The pole which is close to the imaginary axis. So any system, it takes after 5 time constants to reach the steady state. Practically 5 tau, theoretically infinity. We'll solve one problem here. Okay, not on the one problem. Not on one problem. Not on. Find the equivalent first order system. Find the equivalent first order system. To the given second order system. To the given system, for example, to the given system. This is first bit. Second bit, find the system time constant. Find the system time constant. System time constant. So for C of S by R of S equal to 1 by S plus 1. S plus 10. Find system time constant 1 by S plus 1, S plus 10. Come on, tell the answer anybody. What is the equivalent first order system? Completed? Anybody answer? What is the equivalent first order system? Anybody? 0.1 by S plus 1, 1 by 10 S4, correct? 1 by S plus 1. Okay, good, very good, very good. So listen. So here, equivalent first order system means we have to neglect the insignificant pole. Listen here. Next page, listen. So represent the poles and zeros in the S plane. Represent the poles and zeros in the S plane. Represent the poles and zeros in the S plane. So one pole at the origin, sorry. One pole at -1. One pole at -10. The pole at -1 is called dominant pole. The pole at -1 is called the dominant pole. It is a dominant pole. This is a dominant pole. It is a dominant pole. This is called insignificant pole. This is called insignificant pole. This is called insignificant pole. We cannot call all the poles which lies leftmost is insignificant. There is a condition. What is the condition means? Insignificant pole time constant. Insignificant pole time constant must be less than or equal to dominant pole time constant divided by 5 times. Then only the leftmost pole is called insignificant pole. When you want to call a leftmost pole as an insignificant pole, leftmost pole as an insignificant pole, the time constant must be less by 5 times. It should be less by 5 times. What is the time constant of this pole? Tau equal to minus 1 by real part of the dominant pole is minus 1. That means it is 1 second. What is the time constant of this pole? Minus 1 by minus 10, real part of that pole. That means what? 0.1 second. That means how many times less? 10 times less. That's why it is called a insignificant pole. It is called a insignificant pole. This is a dominant pole. So insignificant poles are neglected. Insignificant poles are neglected because even if insignificant poles are neglected, there is no change in the system response. Insignificant poles are neglected. Poles are neglected. Insignificant poles are neglected. Because even if neglected, there is no change. There is no much change in the system response. There is no much change. So slight change will be there, very insignificant effect. There is no much change in the system response. Much change in system response. That's why insignificant poles we can neglect so that the analysis becomes very easy. Insignificant pole neglected, then orderless. Orderless means then the analysis becomes the very easy. So now what happened? I will prove it here. What I will prove? Either consider insignificant pole, either neglect insignificant pole. There is no much change in the system response. Even if you neglected or you consider, both the responses approximately same. Both the responses are approximately, either consider, neglect, both the responses are approximately same. So for example, now see, I will consider C of S by R of S equal to 1 by S plus 1, S plus 10. First I consider both the poles. First I consider both the poles. I consider both the poles. First I consider both the poles. Take care, na? Both the poles I consider. So impulse system response means what? Impulse response you have to find. Impulse response you have to find. System response means impulse response. Impulse response. So that means R of S 1. Then C of S becomes what? C of S equal to 1 by S plus 1, S plus 5. 1 by S plus 1, S plus 5. Partial fractions you find out. Partial fractions. So S plus 10, na, sorry. Partial fractions. S equal to S plus 10 equal to 0. S equal to minus 1. Substitute minus 1 here. Minus 1 plus 10 means 9. So 1 by 9 into S plus 1. Similarly, S plus 10 equal to 0. S equal to minus 10. Minus 10 plus 1. Minus 10. S minus 10. Minus 10 plus 1 means 1 by 9. Minus 1 by 9. So minus 1 by 9. S plus 10. I consider both the poles here. Now find inverse Laplace transform. Then what is C of t you are getting? 1 by 9 e power minus 1t minus 1 by 9 e power minus 10t. Default what? U of t. Default U of t. That's all. That means what happened here? We got the what? Response. System response by considering both the poles. So this e power minus 1t is a what? Dominant pole response. Because minus 1 is a dominant pole. That's why it is dominant pole. Dominant pole response. This is what? Insignificant pole response. Insignificant pole response. See, exponential powers are poles only. The response consists only poles. The response consists only poles locations. E power minus 1 is a pole. E power minus 10 is a pole. The response consists the poles location. The system response consists always poles locations only. So -1 is dominant pole. That's why it is called dominant pole response. -10 is a insignificant pole. That's why I call it is insignificant pole response. Insignificant pole response. Sometimes they used to ask it. Sometimes what they'll ask, they'll use C of t like this. They'll ask what is the system time constant. They'll ask system time constant. They'll ask. Then what you have to do? What your simple logic is to get a system time constant, compare the system response with e power minus t by tau. E power minus t by tau. To get the system time constant from system, this is system response, na? This is system response. So to get system time constant from system response, compare with e power minus t by tau. Exponential term, compare with e power minus t by tau. You compare it here. 1 by tau equal to 1 means tau equal to what? 1 second. 1 by tau equal to 10. What is tau? Tell 0.1 second. If we ask system time constant, we can say here, this is the insignificant pole, na? We can neglect. I can say time constant equal to 1 second. I can say time constant equal to 1 second. Sometimes they'll ask what is the system time constant by giving the response. So simply compare the response with e power minus t by tau, so that you will get the what? System time constant. Okay. Next. Now we'll draw the response for this. We'll draw a response for this. I'll go for the next page. So in the next page, I'll draw the response. What is the C of t we got? C of t equal to 1 by 9. C of t equal to 1 by 9. E power minus 1t minus 1 by 9. E power minus 10t. Default u of t. Now I'll draw the response. This is a dominant pole response. This is a insignificant pole response. Now I'll draw the response. T, C of t, T0 starts at 1 by 9. T0 starts at 1 by 9. T infinity, e power minus infinity 0. That means exponentially decay. And reach the steady state by 5 tau. What is the tau here? 1 second. Here, what is the tau? 0.1 second. Reach the steady state by 5 tau, 5 tau, 5 tau. Tau is 1 second, that means 5 seconds. This is what? Dominant pole response. Then here minus, so here also minus, minus, minus. Now insignificant pole response. Insignificant pole response. Now tell, not C of t. Insignificant pole response. T equal to 0, 1 by 9. So 1 by 9. T infinity, e power minus infinity 0. That means exponentially decay. It decays very fast. It decays very fast within 5 tau. 5 tau means tau is 0.1. That means within 0.5 seconds reaches the steady state. Now you subtract this insignificant pole response. You subtract a insignificant pole response and dominant pole response, then you will get the exact response. If subtract it, then you will get exact response. That is called C of t. 0. What happened here? Insignificant pole response exists for the duration of 0.5 seconds only. It existed for the duration of 0.5 seconds only. This 0.5 seconds subtract here. Or after 0.5 seconds, this is 0.5 for example. After 0.5 seconds, this is 0, na? Whatever the dominant pole response is there, that as it is you will get. After 0.5 seconds, the dominant pole response as it is you will get like this. So this is 5 seconds. Now come to 0 to 0.5 seconds. What happened here? 1 by 9 minus 1 by 9 at t equal to 0 becomes 0. 1 by 9 minus 1 by 9, 0. Now what happened? Of this duration only we have to draw. Here decay is very fast. Here decay very slow. For example, just for understanding, I'll take here 10. I'll take here 9. I'll take here 8. Here I'll take here 10. Same value, not 10. Just for understanding. But decay fast, na? Here I'll take 5. Here I'll take 0. At the same time, I consider T0, 10 minus 10, 0. At T equal to sometime 9 minus 5 means 4. It rises to 4. Next, this is 8 only. This is 8 only. 8 minus 0, 8. That means what happened? It is rises like this. Rises. So this is the response. This is exact response. Exact response. Exact response. Now this is approximately equal to dominant pole response only, na? Approximately equal to insignificant or dominant pole response. Slightly if this axis inclined, then we will get this only. So that's why approximately this is 1 by 9, 0, 5 seconds. Approximately dominant pole response. So slight effect will be there. Approximately it is equal to dominant pole. That means what I can write? This is approximately C of t equal to what I can write? 1 by 9 e power minus 1t. Approximately I can write 1 by 9 e power minus 1t. It is approximate response. This is approximate response by considering the two poles. Now I consider only one pole. For example, now I consider one pole. I'll go for the next page. Now I consider one pole, or I'll write here. If now I consider, for example, equivalent first order system, some students, they written 1 by s plus 1, for example. 1 by s plus 1 is equivalent first order system they written. If I find impulse response, so then what happened? R of s equal to 1. Then what happened? R of s1 means what is C of t? Apply inverse Laplace transform. That means C of s becomes what? 1 by s plus 1. What is C of t? 1 e power minus t u of t. This is C of t. What I told? When I consider the two poles, I got 1 by 9 e power minus 1t. When I neglect insignificant pole, I find the response 1 e power minus 1t. Is both are same? This equal to 1 by 9 into e power minus 1t. Both are same? No, it is different. That means this is wrong. It is not correct. It is wrong. It is not correct. That means what is the equivalent first order system? So C of s by insignificant pole should not neglect directly. What is the transfer function we taken? 1 by s plus 1. 1 by s plus 1 into s plus. This is the transfer. When you want to get the equivalent lower order system, what you have to do? This insignificant pole should be neglected, but only the time constant form it should be neglected. Insignificant pole should be neglected only in the time constant form. So that means what happened? Tell C of s by R of s equal to 1 by s plus 1. This should be converted into time constant form. So that means 10 into, what is the time constant form? 1 plus 0.1 s. 1 plus 0.1 s. Now we should neglect this. That means equivalent first order system is what? C of s by R of s equal to 0.1 by s plus 1. This is the equivalent first order system. Why? You find inverse Laplace transform, which is approximately equal to 1 by 9 into e power minus 1t only. You find inverse Laplace transform, find impulse response. impulse response, you find R of S1. R of S1. That means C of S equal to what? 0.1 by, come on, bolo, S plus 1. 0.1 by S plus 1. Apply inverse Laplace transform. If apply inverse Laplace transform, C of t equal to what? 0.1 into e power minus 1t into u of t. It is approximately what? 1 by 9 into e power minus 1t. Both are approximately same or not? When I consider two poles, we got 1 by 9 e power minus 1t. When I consider even single pole, I got 0.1 by e power, 0.1 into e power minus 1. 1 by 9 is approximately what? 0.1. So equivalent first order system is, equivalent first order is 0.1 by S plus 1. It is equivalent first order system, equivalent first order transfer function, first order system. What is the time constant? Tell now. Pole at -1. Pole at -1 means time constant what? Time constant equal to 1 second. Time constant equal to 1 second. Like this, you have to find equivalent first order. But no need to do like this. Simply what you do, identify the insignificant pole. That bring into time constant form and neglect and then write. Then it will become equivalent lower order system. Why? Because you should neglect you should neglect insignificant pole only in the time constant form. We should neglect insignificant pole only in the time constant form because system gain should not change. For example, see, if I directly neglect here, like this, directly if I neglect, what is the system gain here? System gain becomes 1. But actually, what is the system gain? What is the system gain here? 1 by 10. 0.1 system gain. That should not change. System gain should not change. We add any pole, you neglect any pole, system gain should not change. System gain, you find here, what is the system gain? 0.1. You find the system gain here. What is the first system gain here? 0.1. Both should be same. That's why insignificant pole should be neglected only in the time constant form. Insignificant poles are neglected only in the time constant form. Time constant form. That's all. So equivalent first order is 0.1 by S plus 1. System time constant is 1 second. Last problem, just another 2-3 minutes. Last problem. Find the equivalent transfer function. Find equivalent transfer function. Find equivalent transfer function. C of S by R of S equal to 1 by S plus 1, S plus 10, S plus 20. Come on. Tell the answer, anybody? Option A, 0.05 by S plus 1, S plus 10. Option B, 0.005 by S plus 1. Option C, 1 by S plus 1, S plus 10. Option D, 1 by S plus 1. What is the answer? Anybody? Anybody? What is the answer? B. Very good. B is the answer. Why? Because these two are insignificant pole. This is also insignificant. This is also insignificant. This time constant 1 na. Time constant is 1 second. 0.1 second. Here 0.05 seconds. So these two are insignificant. Comparison always with the dominant pole only. Compare with only dominant pole. 10 times less, 20 times less. Both are neglected. So that means what I can write? 1 by s plus 1. 10 take it common. 1 plus 0.1 s. Next 20 take it common. 1 plus 0.05 s. Then these two neglect. Then what I will get? So 1 by 200 means 0.005 by s plus 1 is the answer. So like this, you have to find the equivalent first order systems. Okay. I'll close here. If you have any doubt, you can ask. Okay. Tomorrow, I'll continue the remain basics. Still some more important basics are there. By tomorrow 6 o'clock, we'll start at SAP 6. Okay. If you have any doubt, you can ask. Hello?
Hello, sir.
Tell Sri Charan.
Sir, I have doubt that for a unity feedback system, if we give in the question open loop transfer function, we will take open loop transfer function, sir.
No. Question you tell. What is the question? Question we tell. Complete
No,
question
sir.
you tell.
If
What is given in the question?
If in the question he gives, find the open loop transfer function of a unity feedback system. If you give open loop transfer function, we will find closed loop transfer function.
Why closed loop transfer function? What is the question you ask? You are asking find open loop transfer function, na?
No, sir, not find. If you give open loop transfer function, we will find closed loop, sir.
For what you want to find closed loop transfer function? That is important. Now, for type I think we need only open loop. For order we require closed loop.
No, sir. I think 5F or 6F page you told one question, sir.
This only?
One open loop transfer function question. Given, I think 4F or 3F.
This only?
No, sir. In question, there, this, sir.
Tell.
Sir, if in the question he did not give open loop transfer function, only if he gives transfer function.
Read the question. What is the given?
Yes, sir. He given open loop transfer function, sir.
That's all.
If he didn't give open loop, he just give only transfer function.
Transfer function of what it will give?
Unity feedback system.
Then it is a what? Which transfer function?
Closed loop.
That's all.
Okay.
Okay, na?
Okay, sir. And
next.
Another doubt. You told that if tau is more, then it will be slow, no, sir. The system will be
slow response. That all I told, na?
But for dominant pole, tau will be greater, no, sir.
Tau down because of dominant pole, system response always becomes very, very slow. That is a drawback of dominant pole, na?
If we take insignificant pole, system will be fast, no, sir. Then we can take
system fast, but problem is what? We cannot neglect the insignificant pole because insignificant pole response very small. So, dekho here, you observe here insignificant pole response. It is very, very small. It is a negligible amount.
Okay.
That's why insignificant pole is neglected.
Okay. Yes, sir.
Next, Rohan. Rohan. Right. Next, Deb. Rohan. Not there. Okay. Next.
Hello, sir.
Tell.
Page number 13F.
Page number?
13F.
Tell. This only.
Yes, sir. Sir, please can you explain again the exact response part before?
Subtract this, na? Just subtract it. You will get exact response. After 0.5 seconds, insignificant 0, na?
Yes.
0 means what is the left?
0.5.
Dominant pole response only left, na?
Yes, yes, yes.
So here to here dominant pole response only. This is same dominant pole.
Okay, sir. Understood.
Then 0 to 0.5 seconds, subtract from this. From this area, subtract this area, na? Here
Okay.
I taken 10, 10, 10, 10, 10 minus 10 means 0. Here 9 I taken, here 4, 5 I taken. That means 9 minus 5 means 4. That means response increasing.
Yes, sir.
And then the here 0, here 8. It goes to 8. This is 8 only, na?
Yeah, right. Okay, sir.
Next. Bala Subramanyam. Lakshmi Prabha.
Sir,
Tell me.
sir, 3F, sir.
3F. Tell me.
So in this, you said for the force response to find, we want to, how can we find that? You said right, sir, 3 types that I didn't get, sir.
Which one?
Finally, you said if we want to find the response, we use the nature of the response or system of the
Nature, system nature you want to find, you have to consider, you have to find impulse response.
Okay,
Because
sir.
impulse response not consists input coefficient. Is there any input term here?
No, sir.
Whereas here see one is there, one is per step.
Okay, sir.
Okay, na?
Okay, sir.
Impulse response not consists input term. Impulse response only system terms consists. That's why it is called system response or system nature.
Okay, sir.
Okay, na?
Okay, sir. Sir, 12F.
Tell.
12. Yes, sir. In this, C of S equal to 9 into S of S, is that normal simplification, sir?
The partial fraction, simple
Okay.
partial fractions.
Okay, sir.
Okay.
Thank you, sir.
Okay.
Good evening, sir.
Good evening. Tell me.
Sir, 6F, sir. 6 page.
Tell me.
Sir, you said that for any system, the system gain is numerator constant upon denominator constant, right?
Yes. For closed
sir.
loop system gain, you have to apply this for closed loop transfer function.
Correct. Sir, on same page, G of S we got 2S plus 1 upon S square.
G of S. Okay.
So then how we will find system gain? Numerator
That is
constant
called
is 1.
open loop system gain. One only.
But denominator constant is 0, no?
Why 0, man? What is G of S can write? Tell. 2S plus 1.
plus
1
1.
plus 2S by. What I can write? Tell. Come on.
S square.
1 plus 2S by. S square into 0, right? Then it will become infinity. 1 plus S0.
Okay. Yes. 1 plus S0.
How can you write it 0, man?
Right. 1 plus
Got it,
S0. Yes, sir. Okay. Thank you, sir.
Okay. Next. Anubhav.
Sir, actually, I am a bit confused in time invariant nature. What is that supposed to mean? Actually, output will vary with respect to time, no, sir. So, what does this specifically means? Time invariant.
Time invariant system, na,
Yeah.
not components, not the response, na.
Okay, sir. So,
Linear time invariant system. RLC values are changes or not changes?
RLC values are not changes.
That means what happened?
What
That
happened?
means what happened? RLC values are not changing, na?
So, the
Not
value.
changing. That means RLC component values are time invariant.
Okay, so component values mean. I mean, we are
Component.
focusing-
What is the LTI system?
Okay.
Got it, na?
Right.
Okay. Any more raise the hand? Next. Madhura.
Hello, sir.
Tell ma.
Sir, yesterday you told condition for relative stability, g of s into h of s is greater than 0.
Ah,
How we got that condition?
how you got that condition? GH greater than 0, then only poles moves left. There only I given explanation. In case GH in G, if I take a negative sign, what happened? Pole where it is moving?
To the right side.
Right side means relatively less stable.
Okay, sir.
GH
And
should be positive, then only more stable.
okay, sir. And
Okay,
sir, page 1F.
1F.
So, how we got transfer characteristics of that RC network?
Find output by input. 0.5 VI na?
Sir, RC network.
RC network also input 0 means what is the output?
0.
Input 1 means what is the output? Exponential rise to 1.
So
Capacitor charges, capacitor how it will charge? It is simply charging curve of capacitor only na?
Sir, but a 0.5 volt output
This
for
is transfer characteristics. Input to output based on this you have to draw this. This is V0 versus Vi, not with T. V0 versus Vi.
But sir, for 1 volt, how we got 0.5?
We take an approximate value at 1 second, for example, 0.5 volts. At same 1 second, if input 5, it will become 5 times increased. That means 2.5. Because linear system means what happened? Input double means output double. Input 5 times increase, output 5 times increase. If I assumed for 1 volt, output is 0.5. If input in case 5 volts, output compulsory 2.5 volts only.
Okay, sir.
Okay, na?
Yes, understood.
Next. Abdul.
Sir. Sir, I missed this topic, sir. Once you tell. I didn't understand C of S by R of S. That why we are taking R of S equal to 1 and this one also. Sir.
Impulse, what is the impulse R of S, man?
Impulse R of S is 1 delta of T.
That's all.
Why we are taking for all the conditions unity feedback only, sir, or any system?
Standard form of system is unity feedback only. The standard closed loop system described in terms of unity feedback only. Okay, na? Hello?
Hello, sir.
Tell.
Unity feedback, I didn't get, sir. 1 second, can you tell?
Standard form of closed loop system described in terms of unity feedback only. That is standard representation. Closed loop
C of S by,
standard form.
this is a C of S. C of S by R of S is the output by input response, sir.
Yes, correct.
ఇప్పుడు ఆర్ ఆఫ్ ఎస్ మనం ఎందుకు 1 ఎప్పుడు 1 తీసుకుంటాం సార్, అది అర్థం కాలేదు.
ఎప్పుడు 1 ఎందుకు తీసుకుంటావా? when you find impulse response then you will take 1. impulse response, system response, both are same.
అంటే మనం కన్సిడర్ చేసే సిస్టమ్ రెస్పాన్స్ ని ఇంపల్స్ రెస్పాన్స్ అని తీసుకోవాలి సార్, ఏ సిస్టమ్ కన్నా.
అంతే. find system response అంటే input should be impulse only.
ఓకే.
ఓకేనా?
ఓకే.
నెక్స్ట్.
ఇంకోటి సార్ హలో, ఇంకోటి డామినెంట్ పోల్, అది అర్థం కాలేదు సార్, ఒకసారి
డామినెంట్ పోల్ అంటే నియర్ టు ఇమాజినరీ.
నియర్ టు ఇమాజిన్ అంటే మనకి వాల్యూస్ S - 1 S - వచ్చాయి కదా, వాల్యూ ఒకసారి ప్రాబ్లం తీయరు సార్.
tell. You should listen, man. Carefully should listen.
I got it, sir, but I have some doubt. We are here. If we are S plus 1 into S plus, we are taking in the form of 1 plus S to ఆ ఫార్మ్ లో తీసుకుంటాం కదా సార్. అంటే కింద S plus 1 S plus 10 అంటే
దాన్ని ఫార్మ్ తీసుకొని ఇన్సిగ్నిఫికెంట్ పోల్ నెగ్లెక్ట్ చేయాలి.
అంటే ఇప్పుడు నేను అంటుంది S plus 1 S plus 10 అంటే 1 plus S to ఆ ఫార్మ్ లో తీసుకుంటాం కదా సార్ అని అంటుంది. formula ప్రకారంగా g of s is equal to k
That is
into
not C of S, that is C of S by R of S, complete transfer function it is. You can take it. What is there? K into 1 plus S of form also you can take.
మరి
what is the use
ఇలా
of that?
ఇప్పుడు ఇలా తీసుకుంటే డైరెక్ట్ ఎలా వస్తుంది సార్ అంటే అర్థం కాలేదు సి ఆఫ్ ఎస్
ఏది డైరెక్ట్ అయ్యా, ఏది డైరెక్ట్, ఏది డైరెక్ట్ అంటున్నాను? సి ఆఫ్ ఎస్ ఇదా? నువ్వు పేజ్ నెంబర్ కరెక్ట్ చెప్పు నాకు. ఇదా
బ్యాక్ అని
టెల్
బ్యాక్
పేజ్ నెంబర్ చెప్పు. చెప్పు ఇప్పుడు చెప్పు.
ఇది సార్ ఈ ప్రాబ్లం సి ఆఫ్ ఎస్ బై ఆర్ ఆఫ్ ఎస్ ఈక్వల్ టు 1 బై s ప్లస్ 1 s ప్లస్ 10 అంటే ఇది మొత్తం అవుట్పుట్ బై ఇన్పుట్ ఇది మనకి ఇచ్చింది. ఇంపల్స్ రెస్పాన్స్ మనం ఎప్పుడు ఇక్కడ స్టేట్ సిస్టమ్ లో వచ్చినప్పుడు ఆర్ ఆఫ్ ఎస్ 1 తీసుకోవాలి సార్.
అంతే, సిస్టమ్ రెస్పాన్స్ మీన్స్ ఆర్ ఆఫ్ ఎస్ 1 ఆల్వేస్.
ఓకే, ఇప్పుడు అందులో నుంచి మనం ఇన్వర్స్ లాప్లాస్ తీసుకొని మనం ఇలా సిస్టమ్ టైం కాన్స్టెంట్ తీసుకొని మనం డామినెంట్ పోలా సిగ్నిఫికెంట్ పోల్
లేదా సింపుల్ లాజిక్ ఐ టోల్డ్ నా. వాంట్ ఈక్వలెంట్ ట్రాన్స్ఫర్ ఫంక్షన్, సింపుల్ లాజిక్ యూజ్ దిస్, నెగ్లెక్ట్ ఇన్సిగ్నిఫికెంట్ పోల్స్.
Okay.
The time constant form and then find equivalent transfer function. That is just for understanding. I explained all that.
Okay, sir.
Simply use this
Okay,
now.
got it.
Okay. Next. Sumant. Sumant. Sumant Pulluru. Next.
Hello, sir.
Tell man.
While finding the type of closed loop transfer function, while finding the type of closed loop transfer function, why we are going for open loop transfer function?
I told na, integrators we can identify only in the open loop form. We cannot identify integrators in the closed loop form.
Means I did not understand, sir.
Integrator means what? 1 by S terms.
Yes, sir.
1 by S terms we can find only in the open loop form. We cannot identify in the closed loop form.
Okay.
Okay, na? Integrators are identified only in the open loop form. That belongs to the system. System defined in terms of G of S only, na?
You are telling, sir. You are telling about error constants, no, sir?
Errors type both are linked.
Okay.
Errors also valid for unity feedback, whereas type also linked with type also valid for unity feedback only.
Okay, sir.
Okay, na?
Okay, sir.
Next, Abhinav.
Hello, sir.
Tell man.
Sir, how we got C of S by R of S is equal to G of S by 1 plus G of S?
That is closed loop transfer function, na?
Can I expand it?
Which page?
Use in every time. I think 3F, sir. I think use.
This one,
Yes, sir.
out of what is the closed loop transfer function? G of S by 1 plus G of S only, na?
Sir, can you explain it, sir?
Control system not studied?
No, sir.
Closed loop transfer function, closed loop transfer function is G of S by R of S, 1 plus G of S. That is a formula you have to remember.
Sir, ఒకసారి ఎక్స్ప్లెయిన్ చేయగలుగుతారు సార్? ఇప్పుడే సార్ వినేది.
ఏ క్లాస్ అవుతున్నావు ఇప్పుడు?
థర్డ్ ఇయర్ స్టార్టింగ్ సార్.
స్టార్ట్ అయింటది కదా?
ఇప్పుడే స్టార్ట్ అయింది సార్. అది వినలేదు ఇంకా.
So this is G of S. The feedback H of S అన్నది అది తెలుసా? అది ఫీడ్బ్యాక్ H of S అని. దీని డెరివేషన్ చేస్తే వస్తుంది. దీని డెరివేషన్ చేయాలా? ఇక్కడ ఏముంటది? ఫీడ్బ్యాక్ సిగ్నల్ B of S ఉంటది. ఇక్కడ ఎర్రర్ సిగ్నల్ E of S ఉంటది. Find the output. What is the output? Tell. What is C of S? G of S into E of S. Yes sir, no? Hello?
Yes sir, yes sir.
What is G of S? Input E of S, na?
Yes sir.
G of S into G of S is called C of S. What is B of S? B of S equal to what?
H of
G
S,
of S into
C of S.
H of S.
Yes.
Then what is G of S? R of S minus B of S.
B of S.
Now substitute and simplify, then you will get the answer. C of S by R of S equal to 1 G of S by 1 plus G of S H of S. You will get this E of S substitute in C of S. What I will get? G of S into E of S, substitute it. What is G of S?
R of S minus B of S.
B of S substitute again.
C of S into H of S.
G of S into R of S minus C of S into
H of S.
now we simplify this, you will get the answer. C of S equal to G of S into R of S minus G of S H of S into C of S. C of S terms take it common. What are you getting? 1 plus G of S H of S equal to what? G of S R of S. Find C by R. What do you got? G by
G of S by 1 plus G of S into H of S.
H of S. H of S 1 na unity feedback na. Here what is mentioned?
Yes, sir. Yes, sir.
That's why I got G by 1 plus G.
Okay, sir. Thank you.
Okay na?
Okay, sir.
Next.
అంటే ఇవన్నీ కంట్రోల్ సిస్టమ్ లో రావా సార్?
ఏవి?
అంటే ఇదే ఇప్పుడు ఇది చెప్పింది.
ఇవన్నీ మీకు తెలియాలి. గేట్ క్లాసెస్ అంటే ఉంటాయి మీకు. సింపుల్ డెరివేషన్స్ అని మీరు చదవాలా. డెరివేషన్లు మీరు చదవాలా. ఇంపార్టెంట్ పాయింట్స్, నీకు క్వశ్చన్స్ ఎలా అడుగుతాడు, కాన్సెప్ట్స్ అవన్నీ మేము కవర్ చేసుకుంటూ పోతాం. డెరివేషన్స్ జనరల్గా క్లాస్లో కవర్ చేయం. డెరివేషన్స్ ఐఎస్ లో కవర్ చేస్తాం. మళ్ళా ఈ సింపుల్ డెరివేషన్ ఇది కంట్రోల్ సిస్టమ్ ఫస్ట్ ఇది ఉంటుంది కదా.
అంటే ఇంకా మాకు స్టార్ట్ అవ్వలేదు సార్, నేను చూడలేదు క్లాస్, అందుకే అడిగా.
ఏ కాలేజీ
సార్?
ఏ కాలేజీ?
ఎంజిఐటి.
ఎంజిఐటా? మన ఇంకా స్టార్ట్ కాకపోవడం ఏందా?
అంటే స్టార్ట్ నేను చూడలేదు సార్ క్లాస్ అది.
మామూలుగా అక్కడ డెరివేషన్స్ అక్కడ చేస్తారు కాలేజీలో. మేమేందంటే
సార్ ఇప్పుడు సెకండ్ ఇయర్ లో జాయిన్ అయితే మరి ప్రాబ్లమే కదా సార్.
మేము డెరివేషన్లు అన్ని చేసుకుంటూ పోతే ఏమవుతుంది, లాస్ట్ కు ఏం చదవాలన్నా మీకే అర్థం కాదు. యూనివర్సిటీకి గేట్ ఎగ్జామ్ కు డిఫరెన్స్ కూడా తెలియకుండా అవుతుంది.
సెకండ్ ఇయర్ లో జాయిన్ అయితే కష్టం అవుతుంది కదా సార్. మరి
ఏం కష్టం అవుతుంది? ఒకసారి ఇది గుర్తుపెట్టుకున్నాం అనుకో, క్లోజ్ లూప్ ట్రాన్స్ఫర్ ఫంక్షన్ అయిపోయా మొత్తం
అదే గుర్తు పెట్టుకుని అర్థమవుతుంది లేండి సార్.
అంతే. ఇప్పుడు ఏంది, ఇప్పుడు ఓపెన్ లూప్ ట్రాన్స్ఫర్ ఫంక్షన్, క్లోజ్ లూప్ ట్రాన్స్ఫర్ ఫంక్షన్స్, కొన్ని ఫార్ములాస్ గుర్తుపెట్టుకుంటే నీకు మొత్తం వచ్చేస్తుంది. సబ్జెక్ట్ చదివి వస్తే మొత్తం క్లియర్గా ఉంటుంది. చదవకుండా వచ్చినా కూడా ఏమవుతుందంటే నువ్వు ఒకసారి ఇది అర్థం చేసుకున్నావు అంటే నీకు కాలేజీలో చాలా ఈజీ అవుతుంది. ఓకేనా? ఏం పేరు నీ పేరు?
అభినయ్ సార్.
అభినయ్. ఓకే. చదువు బాగా చదువు, ఏం కాదు కానీ. ఓకే. హలో.
ఓకే సార్.
అర్థమవుతుంది కదా?
ఎస్ సార్.
అండర్స్టూడ్ నా టుడేస్ క్లాస్?
ఎస్ సార్, అండర్స్టూడ్.
లాస్ట్ డే
అర్థమైంది సార్. మళ్ళీ అర్థం కాకుండా ఒకసారి మళ్ళీ చూసుకున్నాను.
ఒకసారి చూడు, మళ్ళీ చదువు. ఓకేనా? నోట్స్ అలా ఒకసారి చదువు. ఈ డెరివేషన్స్ మాత్రం నీడ్ ఉండేటివి చెప్తాను మామూలుగా. జనరల్గా ఇది సింపుల్ ఎవరికి కంట్రోల్ సిస్టమ్ చదివిన ప్రతి ఒక్కరికి వస్తుంది ఇది. అందులో ఫస్ట్ చాప్టర్లే ఉంటాయి ఇవన్నీ.
నేను ఎక్స్పెక్ట్ చేశానంటే మీరు ఇందులో నుండి కొంచెం స్క్రాచ్ నుండి వెళ్తారని నేను అనుకున్నాను.
స్క్రాచ్ అంటే
ఫస్ట్ బేసిక్.
అసలు నోబడీ విల్ టీచ్ దిస్ ఆల్సో. వాట్ ఈస్ ఎ పోల్, వాట్ ఈస్ ఎ జీరో, దట్ ఆల్సో నోబడీ విల్ టీచ్.
అది ఓకే సార్, అది ఓకే. కానీ ఇదైతే ఇక్కడే కదా సార్ వినేది మేము. సి బై ఆర్ ఈక్వల్ టు జీ ఆఫ్ 1 ప్లస్ జీ ఆఫ్ ఎస్.
అది మీరు చదివి రావాలి కదా, చదవాలి. అది మీరు కొంచెం చదవాలి కదా. ఇంకా చదవకుండా మొత్తం చెప్తే ఇంకా కాలేజీకి కోచింగ్ సెంటర్కు తేడా లేకుండా పోతుంది. అంతేనా కదా? ఓకే. నౌ అండర్స్టూడ్ నా?
సార్ అర్థమైంది సార్ ఇప్పుడు. థ్యాంక్ యూ.
నెక్స్ట్ నవీన్.
Hello, sir.
Tell. Hello?
Sir, as of
Voice not clear.
Sir.
Hello?
Hello, sir.
Tell.
Now it's clear.
Now tell.
Sir, now it's clear. Sir, Laplace of impulse response 1 ఎలా అవుతుంది సార్?
లాప్లాస్ ఇంపల్స్ 1 కదయా? సిగ్నల్స్ అండ్ సిస్టమ్స్ చదవలేదా?
లేదు.
Laplace of impulse 1, Laplace of step 1 by s, that you should know na. Hello?
Impulse function.
Voice not clear.
Hello, sir.
Next. Hello?
Hello, sir.
Tell.
Sir, Laplace of impulse response 1 ఎలా అవుతుంది?
అరే లాప్లాస్ ఆఫ్ ఇంపల్స్ 1 అంటే మళ్ళా ఎట్లా హౌ ఇట్ ఈస్ మీన్స్ ఆస్క్ ద సిగ్నల్ సార్. దట్ ఈస్ సింపుల్ బేసిక్స్ నా.
ఓకే సార్. తర్వాత మనకు టైం కాన్స్టెంట్ డామినెంట్ పోల్ కి చూస్తాం కదా సార్. అయితే ఇమాజినరీ పోల్ కి ఎందుకు చూస్తున్నాం సార్?
దేనికి?
ఇమాజినరీ పోల్ కి సార్.
ఇమాజినరీ పోల్ కైనా ఓన్లీ రియల్ పార్ట్ కన్సిడర్ చేసుకోవాలా.
కానీ మీరు ఫార్ములాలో డామినెంట్ పోల్ కే ఇచ్చారు కదా.
Real part gives the time constant, imaginary part gives the frequency of oscillations.
Okay.
Imaginary part time constant ఇవ్వదు.
ఓకే సార్.
ఓకేనా?
ఓకే సార్.
నెక్స్ట్. అయిపోయిందా
సార్? దట్స్ ఆల్ సార్. అండ్
చంద్రబాబు అని పేరు?
నవీన్ సార్. నవీన్.
ఓకే. నెక్స్ట్ ఎనీ మోర్? చంద్రబాబు.
Hello.
Tell.
Sir, 3F, sir. No.
Tell.
Sir, you said that now e power of minus t u of t is stable and bounded output. How it is, sir?
3F, where it is? Bounded. Yeah, here bounded na. E power minus infinity. T tends to infinity, substitute. What is the answer?
T tends to infinity.
E power minus infinity, substitute.
0, sir.
0 na?
Yes, sir.
0 is a bounded or unbounded?
Bounded.
And then stable.
Okay, sir. 14F, sir. Sir, you said that now 1/9 e power of minus t not equal.
1/9? Both are equal na, approximately.
Approximately equal, sir.
Approximately equal. 1/9 is approximately equal to 0.1 na?
Yes, sir. Oh, that is not, sir. So you given the 1/s plus 1 transfer function.
Then it is not equal na. 1. You will get here 1. Here 1/9 not equal. That's why it is wrong.
Okay.
Some students directly they'll take 1/s plus 1, which is wrong. Okay.
Okay, sir.
Next, Jyotishwar.
Sir, what are the conditions to system to be stable, unstable, marginally stable, and conditionally stable, sir?
It will come, na? It will come. Stable means response should be bounded. Marginal stable means oscillatory.
Sir,
means unbounded. What is there, man?
Stable ante bounded, unstable ante unbounded,
unstable ante response goes to infinity, unbounded.
Okay.
Marginal means oscillatory, constant amplitude and frequency of oscillations. It never settle at a particular value.
Okay. Conditional stable?
Conditional stable means certain k only stable. Certain range it is stable. 0 to 100 stable. More than 100 తీసుకుంటే then it is unstable.
Okay, sir.
Okay na?
Okay, sir.
Any more?